do to track down users, not to track down their habits, but to track down who they are if you, for example, change something in the web application, okay, and you're not logged in. So what is going to happen is that instead of betstore.com, you go betstore.com, then, for example, question mark, and then an alphanumeric string. Okay, so essentially, you're gonna have that the URL is changed depending on who is using the application. This is basically what Google used to do in the past. I don't know if it does it already, even nowadays. Basically, if you were not logged in into Google and you were using their web applications, you were basically seeing that the URL was changing. Okay, that's because Google was tracking you down, saying, okay, you changed the language, you changed some preferences. Okay, what did you change? Who are you? How can I track you down? And this was done by changing the URL. Or we can inject a header. Okay, so we can inject a header inside the connection, the response, and then that header is going to be used to track down Tommy. Okay. So there was a guy who had connection problems. Don't worry, everything that I explained is related to persistence, same topic. Okay, so now we'll show you how to configure persistence. Persistence is configured at service level. Okay, so we edit the service, then we go to the load balance section, and then as you can see, we have persistence method. If we click on persistence method, we have source IP, cookie insert. This is the cookie generated by the WAF. Cookie passive. The cookie is generated by the web server, and the WAF will get the value. HTTP header, and then we just put the header name that we want to use, and the WAF will generate a random string. Or URL parameter. Again, we put just the name of the URL parameter, and the WAF will generate the string for you. Okay. You also have a timeout that you can configure for persistence. So how many seconds a user can idle on that session. Okay. So for example, if after 10 minutes the WAF doesn't see any traffic for that user, then the WAF will completely forget persistence. So if the user will create another connection, maybe it will be load balanced to another server. There is also another thing that you can configure for persistence that it's called the failover method. The failover method will allow you to tell the WAF what to do in case there is a problem with a backend server. Okay, let's say we have 3 backend servers, and then a user is actually on web server number 3, let's say, and the web server number 3 all of a sudden crashes. Okay, what the WAF should do with this connection? You have 2 options. You can load balance the connection to another server, or you can generate an error message. Okay, now why do we have this option? Because as I said before, depending on how your web application is configured, is designed, if you load balance the request and you don't have some kind of synchronization mechanism between the backend servers, when the user will be load balanced to another server, then he will basically lose all the context. So maybe he will be logged out. So imagine if this is during a checkout process. The user is doing the checkout, maybe he's selecting the credit card number, and then he's logged out. Was the transaction successful? The user that will not know. Okay, it doesn't know what happened. On the other hand, if you select error, this will generate an error page. So we are telling the user that something went wrong, and so the user somehow expects that he has to re-log in or redo something. Okay, so it is up to you how you want to handle the failover methods. Okay. Do you have any questions regarding anything that we have seen so far? All right. So these features that we have covered, load balancing and persistence, can be classified as application availability. Okay, so the WAF will make sure that your service is available no matter what happened to the backend service up to a certain point, right? The next couple of features that we will see can be classified as application acceleration. So the WAF can accelerate the way that your web applications are delivered to the end users. The first feature that we will see is called connection pooling. Now, connection pooling is a very nice feature that will allow you to open, or actually will allow the WAF to open a preset number of connections, okay, TCP connections. So when you configure a backend server, the WAF will actually open these TCP connections, okay? Then we put all these TCP connections into the pool. And what is going to happen is that when we will start to receive the requests, the request will be then in the backend part will be then encapsulated in these open TCP connections. Okay, so the WAF doesn't have to open a TCP connection for every request that is getting in the front end. Remember that the WAF is a reverse proxy. Okay, so this is a TCP connection. This is another TCP connection. Okay, and if you are wondering what happened if the WAF is configured, is deployed in bridge mode, if the WAF is deployed in bridge mode, everything that we are talking about in this section doesn't apply. There is no load balancing, there is no connection pooling, there is no caching, there is no compression, there is nothing. Okay, so this is only valid if the WAF is deployed as reverse proxy. All right, so what is going to happen is that we have this pool of connections. This request will use the open TCP requests, and if it is necessary to open another request, because maybe the front end is receiving a lot of requests, then a new request will be opened, and the first request that is going to be freed up will be deleted, and the new request will be added into the pool. Okay, so they will actually cycle. So we try to maintain as many connections as possible open to the backend server. Now, this has many advantages. For example, the user doesn't have to wait for the second TCP connection to open. Okay. Now, when a server is under load, it might take a while before a TCP connection is actually open. And remember, TCP has to do the three-way handshake, right? So SYN, SYNACK, ACK, okay, for each request. And remember, each browser opens from 6 to 8 TCP connections with HTTP1 to get the content. So we're talking about a tremendous amount of TCP connections are going to be open to our web servers. Okay, by using connection pooling, the user doesn't have to wait for this part, for the backend part, because they're already open. All right, they are just used. Also, you are going to reduce drastically the load on the backend servers. Why? Because the connections are already established. They are already in the transaction table. Whereas if you don't use connection pooling, for every single connection, the server has to do this three-way handshake. And then he has to put the half open connection into the transaction table. And then he has to update the transaction table to then say that that connection is fully established. And then when the connection is finished, he has to remove the connection from the transaction table. Right? So it is a lot of work for the backend service, a lot of CPU cycles that are wasted just by creating and tearing down TCP connections. With connection pooling, we're going to reduce this load on the backend server. Now, where do we configure connection pooling? Connection pooling is configured at server level. Okay, so you have to edit the server. Then if you scroll down, you have in the advanced configuration part, you have, in the connection pooling part, you have that connection pooling is enabled. Okay, then in the server configuration part, you have the maximum number of connection, maximum established connection, and then you have the maximum request, maximum keep alive, maximum spare connections. Okay, so connections that can be used in the pool, and then you have timeouts and so on. Now, one important thing is that for the front end, okay, of course, we cannot use connection pooling in the front end because it doesn't make sense. In order to protect the front end, we have a session timeout. Okay, so this session timeout means that every 60 seconds, if that session is still there, still in place, it will be destroyed. Okay, this might be a good timeout or not. Okay, so that's for the front end. The front end is the service, of course. Now, another quick note regarding connection pooling. If you enable HTTP2 in the front end, okay, HTTP2, as we said on day one, uses only one TCP connection, right? One TCP connection, and then it will multiplex all the requests into this one TCP connection. Now, what is going to happen if our backend server doesn't support HTTP2, but it only supports HTTP1 and 1.1? Well, in that case, we can use connection pooling to then take all the requests that are multiplexed into this single TCP connection, and then put this request one by one into the open requests of the connection pooling. Okay, so we use the pool of connections to then take all the requests and say, okay, you go there, you go there, you go there. When we get the responses from the backend server, from this connection, then the WAF will use in the front end that single open TCP connection to then multiplex all the responses into that single TCP connection. Okay, so connection pooling is used when HTTP2 is enabled. All right. Now, the next feature that we will see is caching. Now, caching can be used, of course, only for HTTP services, okay, or HTTPS. And what is going to happen with caching is that we are telling the WAF to save in its memory some static content. Okay, so essentially, we are using the WAF memory to save images, PDF files, any kind of static content like, for example, HTML pages, XML files, and so on. Now, what memory? The RAM. Okay, we don't use the disks in the WAF. We use the fastest memory that we can use for caching. By default, the system uses up to 20% of its RAM for caching if caching is enabled. So if you have, for example, a virtual machine that has 4 GB assigned to the template of the VM, and you enable caching, by default, up to 800 MB will be used for caching. So you have to think about what is the load of the system. I am using caching, yes. How much caching will actually be will increase the load on the system in terms of memory consumption. Okay. Now you can enable caching for a whole service, or you can enable caching as content rule level. Okay. By the way, this is also valid for persistence. Okay, you can enable persistence at content rule level. Now, the good thing about caching is that since the content is already in the WAF, when the user is requesting a page, the WAF doesn't have to request the content to the backend server. It will say, okay, I'm going to get the content that I don't have, and whatever I don't have, I will include it in the response. So in the backend, I might have only 2 items that are downloaded from the backend server, and all the rest are provided by the WAF. Okay? Now, this, of course, will reduce, again, will reduce the time that the user has to wait to load the page of our web application. We will reduce our backend bandwidth. It will reduce the load into of our backend service. Why? Because we have less requests that have to be processed by the backend server. With caching, we can also use compression. Now, compression will basically tell the WAF to compress some objects that are compressible. Okay, don't try to compress JPEGs, PNGs, and so on, because the WAF will actually try to do it, but you will just waste resources in the WAF. You will not gain anything in particular for those content types. So you are going to tell the WAF to compress like HTML files, again XML, and so on. What is happening is that then the compressed object is then forwarded to the web browser. The web browser knows how to handle compressed elements. Okay, so don't worry about that. All modern web browsers, when they see compressed elements, they will decompress the element and then they will parse it. Okay, so no problems with this. Now, compression has a lot of advantages because it will reduce the bandwidth that costs a lot of money, the WAN bandwidth. Okay, because the objects are smaller, so you're going to use less bandwidth to transfer these objects. And also, since the object is smaller, then it is faster to transfer from the WAF to the web browser. Okay, so again, the user experience is improved. Now, you can enable compression at service level, so everything, okay, in the service, or a content rule level, just for a specific part of your web application. Now, just a quick note regarding compression and web servers. Normally, as a best practice, web developers and system administrators will tell you to enable compression at web server level. Okay? Don't do that. Don't enable compression at web server level. Let the WAF compress the content for you. Why? For 2 reasons. First reason, load. Okay, you are offloading this task to the WAF, which is a device that is dedicated to handle this type of traffic. Second reason, and maybe it's the most important reason, let's say that the web server has created a response, and in the response we have a credit card number. Now the web server is configured to compress. So what is going to happen is that the whole body, the response body, will be compressed. Now, what is going to happen to that credit card number? It's not a credit card number anymore. Why? Because it's compressed. Okay? So then the response will arrive to the WAF. Maybe the WAF is configured to do data theft protection, and it will look for a credit card number which is not there. So then it will forward the response to the user, and the user will see the credit card number. Okay? So don't do that. Don't compress at web server level if you have a web application firewall in front of your web servers. All right? Now, how do we enable compression and caching? We have to go to Websites, Traffic Management. There is a question. Does the WAF do not compress the response if the web server compresses? This is actually a good question. Normally, the WAF analyzes the response without touching it. Now, since the latest versions of the firmware, the WAF didn't decompress the response. But just to be extra certain, I will check this with engineering to see if maybe something has changed with 8.1, okay, which is not documented anywhere. Okay, so I will send you an answer about this. What is actually happening with 8.1? Maybe they have included the possibility to decompress the response before it is parsed. Okay, and I will give you an answer. Yep. So caching and compression are configured, as I said before, at service level, or if you have a content rule, you will see the content rule in this page. Okay, in this case, we don't have content rules, so we only see services. Now, for caching, you just edit the service, and you turn it on, and you specify the file extensions, okay, like .png, comma, .jpg, and so on. Okay, then you specify a minimum and a maximum size for the objects. Okay, when it makes sense to start to cache the object. Okay, maybe something that is below 256 bytes, who cares? Something that is bigger than 256 bytes, kilobytes, sorry, maybe it's too much. Okay, but nobody will actually stop you from saying, I want to cache elements that are 2.5 megabytes big. Okay, so basically this is how you tell the WAF to configure caching. Okay, by specifying sizes, file extensions, and what else? You can put expire age. Okay, this is what the WAF will tell the browser and saying, look, this content is valid for 60 minutes. Okay, after 60 minutes, please download this content again. Okay, normally this is done with a 3 or 4. When there is another request, the WAF will say, you have the content, you just use the content that you have. Okay, I will not provide any new content for you. So this is basically what you do with caching. If you want to change the default values for caching, you go to the advanced system configuration page, and at the bottom, if you have the advanced settings enabled, you see max cache size, and you have 20% of the memory. If you want, you can increase this number or decrease it. Just be careful, right? Because the impact it can be it can affect the whole system. Now, for compression, you essentially do the same thing. The only thing is that you specify content types and not file types. So here you should put, for example, image PNG. Okay, and this will basically be the equivalent of .png. And you specify the minimum size of elements that make sense to compress. Okay, so in this case, everything that is less than 8 kilobytes will not be compressed. Okay, will basically go and transferred uncompressed. If you enable caching and compression at the same time, if an object has to be cached and compressed, then that object is first compressed and then saved in its compressed state into the cache. Okay, so this will save a lot of time and a lot of resources to the WAF, for the WAF, saying, okay, I will do this operation only once. Okay, we compress and cache. All right, so we don't have to compress all this object and again and again and again. One note regarding caching: don't try to cache dynamic pages, because this will destroy your web application completely. Okay, I've seen very bad things happening if you try to cache dynamic pages. Right? One of the things that happens, for example, with caching servers during Christmas time, the last year, Steam was actually delivering pages, cached pages to users that were not the users that were logged in at the moment. So you were logged in with your account and you were seeing the information about another user. Okay? This happens because the caching systems were caching dynamic pages. There were no synchronization between them. There was no synchronization within sessions. What you were seeing is dynamic page generated for a user that was not you. Okay, so don't do it. Now, the last topic, I think we can actually finish before our lunch break, which is good, is called web translations. Now, web translations will allow you to manipulate requests and responses before they are forwarded to the backend servers or to the web browsers. Now, we have different things that we can do with web translations. For example, we can use URL translation to do mapping of URLs. Let's say that, sorry, but I am writing with my mouse. So let's say that we have a website that is www.bn.com. Okay, now internally, this website is defined as app1.bn.local. Okay, now what you do with the WAF, you configure a URL translation saying that www.bn.com should be mapped internally, translated to app1.bn.local. All right. Now let's see that the web developers have created a new version of the web application. Okay, and the new version of the web application, it can be found in app2.bn.local. Okay, so they coexist, they can coexist, and now you want to put this application into the production environment. Okay, you want to make it public, you want to publish this web application. What you do with URL translation, you remove this translation and you point to the new application. Okay, so this will allow you to easily switch between one version to another one. This is just an example, okay, of what you can do. If you want to go back, you then remove this, okay, and you then restore the old mapping. Okay, again, I'm using the mouse, it's not the best way. This is URL translations. Then you have HTTP response request and response rewrite. Now, these are used to manipulate HTTP requests, the content, and HTTP response. Okay, so what you do is basically you get the request and then you analyze the request and then you have a header. You change that header before it is forwarded to the backend server. This is also used for to pass the public IP address of your clients to the backend servers. Remember, the WAF is a reverse proxy. The backend servers will never, ever see the public IP address of your clients in the network information, okay? Unless you enable client impersonation in the WAF. But otherwise, the backend servers will always see the public IP, the local IP address of the WAF. Now, with the request rewrite, we can basically create a rule saying when the request is going through the WAF, please add a new header that could be, for example, x forwarded for, and put the public IP address of the client, and then forward this request to the backend server. The backend server, of course, has to be configured in a way that he is able to understand the HTTP header and say, okay, that's the public IP address. This is what I'm going to use for my logs, for my tracking mechanism, and so on. Okay? Now, the same can be done for the response. We can inject headers in the response because maybe we need it for the web application. And we can change the body. Okay, this is web translations. This is what web translations does. We are going to search for a string anywhere in the text of the body, So we analyze the response body, and then we are going to replace this string with another string. Okay? Now, how do we configure all this in the web? We go to websites, websites translations, and the first thing that you have to do, you have to make sure that you select the right service, which is called website in this page. Okay? Then you configure your URL translation by giving it a name, an outside prefix and domain, and an inside prefix and domain. That's it. Okay? Then you add it into the system. For the request and response rewrite, look what we have here. Default request rewrite rule 1. This is a default rule that you will find in all web application firewalls. And this says insert and header. And the header name is x forwarded 4. The old value is anything. Okay. And the written value is $src underscore address. So what is this? This is a variable. Okay, you can use variables in these rules. Okay, so this will inject the public IP address of the client. Now, if you are wondering, how do I know when I can use variables and what are these variables? Where are these variables? Click Help and scroll down. You will see these are all the variables that you can use. Okay, you can use the URI, destination address, information about the certificate, authentication user, password groups, domain, SSL protocol version, and that's it. Okay, so these are variables that you can use. Everything is actually explained very well in the handbook if you want to know more about these variables. Then the same can be done for the response rewrite. We can insert a header, remove, rewrite a header. For example, remember cloaking, where you can strip out the header of a web server. Okay, say the web server says server, Apache, blah, 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 blah. Now, you have two options. You can use cloaking to remove that header, so you don't do information leaking with that, or you can achieve something that is called security by obfuscation. Okay, so what you do is basically you rewrite the server header, and even if you're using Apache, you rewrite that server header to use IIS. Okay, so what is going to happen is that if you have an automated scanner, the automated scanner would then see the IIS header and will say, oh, look at that, that's a Microsoft server. I can try to do this, this, and that. That would never work because you are running maybe Apache on a Linux server. Okay, so this is something that you can achieve with the response rewrite. And finally, we have the response body rewrite. Now, response body rewrite is something that you have to configure very, very specifically. Okay, so you have a rule name, you have a sequence number, you then have a host match and a URL match. Okay, because this uses quite a bit of resources, so be very specific and then put the search string here, whatever you want to change, and the replace string, okay, the new value. This can change anything, okay, that is in the response. It can change for example, the location of a JavaScript. It can change words inside the page. It can change location of images. It can change links, for example, like instances itself. All right. Now, using the interface, sometimes this web interface, sometimes, especially for these rules, is a little bit annoying because you have to write in the fields and then you have to add and so on. You see that we have a new button on top of add that is called bulk edit. Whenever you see bulk edit on the web, it means that you will see this pop-up window when you click on bulk edit, and basically you can write, like if you're on a text editor here, or you can copy paste your values into this blank input field, basically. You just have to be careful to respect what these headers want. Okay, so this is basically a comma-separated, these are comma-separated values. Okay, so you have to specify that the first is a rule name, then you can say comma, and the status is on. And then you have the outside prefix, that could be whatever. Okay, if you want to see an example, let's open the rules that are already created. Okay. So this is what they look like. So you have the name, the status, what they do, the action, the header name, the hold value, the new value, the condition, and basically the status and processing. Okay, so it has to continue to process the other rules or not. So you can configure the WAF this way. One of the questions that I always get when I arrive to this point of the configuration of the WAF is that if we support scripting languages. Okay, so there are some products on the market, some web application firewalls, where you can create scripts using maybe the WAF, their own language, and then these scripts will be executed depending on some events. Okay, they can change content, they can rewrite headers, they can pull information from a backend server, and so on. We don't do it. Okay, you cannot use scripting in the WAF. The reason behind this is that we wanted to give you an interface that you can use. Okay, so you don't have to learn a new programming language just for the WAF, which you will never use again or any other project. So giving you an interface, we think it's the best way to go. We tell you what you can do. You just have to obey these fields, and that's it. Okay, so we don't support scripting, but we still have the REST API. So REST API will allow you to create scripts to configure the WAF, depending on events. But this is another story, right? You have to have a system, and then in this system you create the scripts, and then using the REST API you interact with the WAF. Okay, but that's different than what other products have. Okay, do you have any questions regarding anything that we have seen today?